Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
Hey everyone, excited to dive into today's topic. Sounds like we're wrestling with some big questions today.
Definitely. The title alone, X, Master as Foundation, Can We Lead on Humanity's Last Exam? Pretty dramatic, right?
Dramatic, but it does capture the stakes, doesn't it? I mean, if we're talking about AGI, we're talking about a potential paradigm shift for humanity.
Exactly. The core question seems to be, how do we build machines that not only perform tasks, but understand, reason, and ultimately exhibit some form of agency? And perhaps more importantly, how do we understand that agency?
Right? And the implication is that if we don't get it right, if we build these systems without understanding their agency, we might be setting ourselves up for, well, not so great outcomes.
That's the doomer scenario, yeah. But I think it's also about building systems that are actually useful and aligned with human values. It's not just about avoiding catastrophe, it's about creating genuine progress.
Progress that's built on a solid foundation. And I think the X, master part of the title implies a fundamental understanding, a mastery of whatever it is that enables true intelligence.
Okay, so let's unpack this a bit. What does mastery even mean in this context? I think that's the key question. Is it about achieving perfect accuracy and prediction? Is it about passing some kind of abstract intelligence test? Or is it about something more fundamental, something related to the underlying mechanisms of intelligence itself?
I think it's about building systems that can learn and adapt in unforeseen circumstances. It's not enough to be good at the tasks we train them on. They need to be able to generalize, to reason about novel situations, to handle the unknown unknowns.
Yes, and that's where I think the current deep learning paradigm falls short. It's fantastic at pattern recognition, at interpolating between data points it's already seen. But it struggles with extrapolation, with reasoning about things it hasn't seen.
I agree. It's brute force, really. Throw enough data and compute at the problem, and you can get impressive results. But it's not understanding in any meaningful sense. It's just sophisticated curve fitting.
Right, it's like memorizing the answers to a test without actually understanding the underlying concepts. You might ace the exam, but you're not going to be able to apply that knowledge in a real world situation. That's where the concept of agentic interpretability comes in, I think.
Agentic interpretability, yeah. I see that as, can we actually understand how the LLM makes its decision? What's the chain of reasoning? What information is it prioritizing? To me, that feels like a critical step towards real AGI.
But how do you achieve that in a system as opaque as a deep neural network? It's a black box. You can look at the inputs and the outputs, but what's happening in between is largely a mystery.
Exactly. It's like trying to understand how a city works by only looking at the traffic patterns. You see the flow of cars, but you don't understand the underlying infrastructure, the zoning laws, the social dynamics that shape that flow. It feels like we need to peek under the hood, beyond correlations and into the actual machinery that dictates the thoughts.
And that's where I think neuroscience comes in. We have a working example of a truly intelligent system, the human brain. We may not understand all the details, but we have a pretty good understanding of its architecture, its components, and how they interact. We could apply those biological principles.
Okay, interesting. So you're saying, let's look at the brain, see how it achieves agency, and then try to replicate that in AI. But the brain is incredibly complex. How do you even begin to distill that into something that's implementable in silicon?
That's the million-dollar question, isn't it? I mean, we've been trying to reverse engineer the brain for decades with limited success. I think the key is to focus on the principles, not the details. The brain is a messy, evolved system. We don't need to replicate every neuron and synapse. We need to understand the underlying algorithms.
And I think one of those underlying algorithms is related to spatiotemporal reasoning. The brain is constantly tracking the position of our bodies in space, the passage of time, the relationships between objects in our environment. It's building a dynamic, constantly updated model of the world. And that model is crucial for planning, decision-making, and ultimately agency.
Yes, and the reward system. The brain's reward system plays a crucial role in motivating behavior, in driving us to pursue goals. It's not just about immediate gratification. It's about balancing short-term rewards with long-term planning. And that's something that current AI systems often struggle with.
So you're saying we need to build AI systems that have a better understanding of their environment, that can reason about space and time, and that are motivated by a more sophisticated reward system. But how do we do that? How do we move beyond the limitations of current deep learning architectures?
I think we need to move towards neuro-symbolic approaches. Combine the pattern recognition capabilities of neural networks with the reasoning power of symbolic AI. Build systems that can learn from data but also represent knowledge in a structured, explicit way.
And that can translate between different coordinate systems. A system that can seamlessly switch between pixel-based visual representations, symbolic descriptions, and physical coordinates in space. That's the kind of flexibility we need for true intelligence.
Exactly. And maybe we can take inspiration from the brain's hierarchical organization. The prefrontal cortex and basal ganglia, for example, play a crucial role in strategic decision-making. Mimic that layered structure in our AI systems, and maybe we can unlock more sophisticated strategic reasoning.
Okay, so we're talking about a hybrid approach, combining deep learning with symbolic AI, incorporating spatiotemporal reasoning, and drawing inspiration from the brain's architecture. That's a pretty ambitious agenda. But is it feasible? Can we really build systems that are this complex?
I think it's the only way forward. The current approach of just scaling up deep learning models is hitting a wall. We need a new paradigm, a new way of thinking about intelligence. And I think the brain provides a valuable blueprint.
Yeah, and think about self-driving cars, for example. They rely heavily on deep learning for perception, but they also need to reason about space and time, to predict the behavior of other vehicles, to plan a safe route. They're already incorporating elements of spatiotemporal reasoning and symbolic AI, but it's still a very brittle system. It struggles with unexpected situations, with edge cases that it hasn't been trained on.
Right. It highlights a major limitation. They don't truly understand what's going on. They're just reacting to patterns. If a ball rolls into the street, a human driver instinctively understands the potential danger, the possibility that a child might be chasing after it. A self-driving car might not recognize the ball at all, or it might not understand the implications of its presence.
Okay, I see your point. But isn't it possible that, with enough data and compute, deep learning models could eventually learn to handle those edge cases? Isn't it just a matter of scaling up the models and training them on a more diverse data set?
I doubt it. I think there's a fundamental limit to what you can achieve with purely statistical methods. You need explicit knowledge representation, you need the ability to reason logically, to make inferences based on rules and relationships.
And you need a proper framework for representing space and time. Deep learning models treat all data as a single monolithic space. They don't understand the relationships between different coordinate systems. They can't translate between pixel-based representations and symbolic descriptions. And that's a huge limitation.
Exactly. It's like trying to understand a map without understanding the concept of scale or projection. You might be able to identify certain features, but you wouldn't be able to navigate effectively. That's how deep learning models are navigating the world blindly without a true understanding of the underlying structure.
So, we're back to the X, master part of the title. What is that X, master? What is the fundamental understanding that we need to unlock true intelligence?
I think it's a combination of things. It's neuro-symbolic reasoning, it's spatiotemporal awareness, it's a sophisticated reward system. But most importantly, it's a framework for representing knowledge in a structured, explicit way.
And for translating between different coordinate systems, a system that can seamlessly switch between different ways of representing the world, that's the key to unlocking true flexibility and adaptability.
And I think that the brain holds the key to understanding how to achieve all of that. By studying the brain's architecture, its algorithms, and its mechanisms, we can gain valuable insights into how to build truly intelligent machines.
Okay, I'm convinced. The current approach to AI is hitting a wall. We need a new paradigm. But where do we go from here? What are the next steps?
I think we need to invest more in neuro-symbolic research. We need to develop new algorithms that can combine the strengths of neural networks and symbolic AI. And we need to build systems that can learn from data, but also represent knowledge in a structured, explicit way.
Yeah, and we need to focus on spatiotemporal reasoning. We need to develop new ways of representing space and time in AI systems. And we need to build systems that can translate between different coordinate systems.
And from my perspective, we need to double down on neuroscience. We need to study the brain in more detail than ever before. We need to understand its architecture, its algorithms, and its mechanisms. And we need to use that knowledge to inform the design of our AI systems.
Right. So, more funding for neuro-symbolic AI, more research into spatiotemporal reasoning, and more emphasis on neuroscience. That's a pretty clear roadmap. But what about the ethical implications? If we're building truly intelligent machines, what are the potential risks?
That's a whole other can of worms. But I think the key is to build systems that are aligned with human values. Systems that are transparent, accountable, and controllable. And I think that neuro-symbolic AI offers a better path towards achieving that than current deep learning approaches.
Agreed. Because if we understand the algorithm, it allows us to shape the values that drive the agent.
Absolutely. By understanding the underlying mechanisms of intelligence, we can ensure that our AI systems are not only powerful, but also beneficial to humanity.
Well, that's a hopeful note to end on. It sounds like we have a long road ahead, but a clear direction. More research, more collaboration, and a deeper understanding of the brain. That's the key to unlocking true intelligence.
Yes, and don't forget the ethical considerations. We need to build AI systems that are not only intelligent, but also aligned with human values.
And that can reason about space and time. That's the key to unlocking true flexibility and adaptability.
And perhaps most importantly, that understand themselves, that exhibit some form of self-awareness. That's the ultimate goal. And it's one that will require all of our collective intelligence to achieve.
Awesome. Thanks everyone for the super interesting discussion. It's been a great deep dive.
Thanks for having me. Always a pleasure.
Likewise. Until next time.
Thank you for joining us on Cognitive Spirals. We hope you found this discussion stimulating. Until next time, keep exploring.